Hello, welcome to the second half of combining random variables. Now, we have to look back at what we did in the previous lesson, and we look at the x variable with the mean, variance, and standard deviation. And we didn't really look at the y variable, but here are the values. So you might want to take a second and fill these in. We have the mean, the variance, and the standard deviation. And I got this just by plugging these into my L1, these into my L2, and doing a one variable stats of L1, comma L2. So now that I have those, let's see what happens when we combine them. Now this is a little bit different than what we've done in the last couple of videos. Now first off, we're going to add x and y. This is different than what we were doing before when we do 2 times or 3 times. Now when I want to find x plus y, if I take a random variable here and add a random variable over here, what are the possible solutions? I could take 2 plus 4 and get 6. I could also do this. And we can look at 2 pages at once. Wonderful. I could take 2 plus 5 and get 7. 2 plus 6 and get 8. Now, if I want to do 3s, I could do 3 plus 4, and that's 7. 3 plus 5, 8. 3 plus 6, and I get 9. For my sample space for x plus y will be 6, 7, 8, and 9. Now my sample space for x minus y is 2 minus 4, negative 2, 2 minus 5, negative 3, 2 minus 6, negative 4, 3 minus 4, negative 1, 3 minus 5, negative 2, and negative 3. So this is my sample space for x minus y. Now we have to think about the probabilities. The probabilities of each of these occurring. Now, the probability of getting a 6, I get by doing 2 and a 4. And assuming that these are independent random variables, I can find that probability by multiplying those together. So I have 0.25 times 0.3, and that would give me 0.075. So on this next page, x plus y, 6 is 0.075. Now 7 isn't quite as easy. Maybe I'll get rid of this page. We don't need that anymore. 7 isn't quite as easy because we can get 7 two ways. There's the 2 and 5 and the 3 and 4. And we have to check both of those values. So 2 and 5 would be 0.25 times 0.2, which would be 0.05, plus 3 and 4, that would be 0.75 times 0.3, which is 0.225. And when I take those and I add them together, that's going to be 0.275. So I'll erase this, and I'll write 0.275. Now to get 8, I can get 8 by doing 2 and 6, which is 0.25 times 0.5, which is 0.125. And I could do 3 and 5 to get it. So 0.75 times 0.2, that's 0.15. So when I add these together, I'll get 0.275. Finally, for 9, the only way we can get 9 is 3 and 6. So that's 0.75 times 0.5, so 0.375. Now we can find the mean and standard deviation like normal using our calculators. All right, now to get those, these are the values that I came up with. Try it on your calculator and make sure you can compute the same values. Now we do the same thing for subtraction to find the values of negative 1, negative 2, negative 3, and negative 4. So pause the video and see if you can find the correct probability. All right, I filled out the probabilities and found the means the variance and the standard deviation of each of them. Now what you should be saying is, holy cow, the means are completely different, but the standard deviation and the variances are exactly the same. It doesn't matter if I add the random variables or subtract the random variables, those are the same thing. It's actually pretty amazing. And here are a couple rules based on this. So when we add the random variables, what we're going to do is take the random variable of x plus the mean of x times the mean of y. When we subtract them, it's the mean of x minus the mean of y. That seems pretty reasonable. These ones are a little surprising to people. To find the new variance, what I do is take the variance of variable x, and then I take the variance of y, and I just add them together. And the shocking one is here. I do the same exact thing when I subtract the random variables. It's pretty confusing to people because they think it's a little counterintuitive, but it is true. Now when I want to find the standard deviation, now I'm just going to square root my variance formula. Some people call this the Pythagorean Theorem for statistics because we're square rooting a squared plus b squared, kind of. And it's the same thing, same rule over here. You square x, square standard deviation for y, and square root it. Now, if we have more variables than just two, we use the same formula. We just add another variable. So it's just going to be the mean of x plus mean of y plus mean of z. When we subtract them, and when we do the variance of x plus variance of y plus variance of z, and here we're also going to add those variances of x, y, and z. And the standard deviation, we could write that formula, but it's just this, and we're going to square root it. All right, hopefully that's enough to do any work.